welcome back. A few episodes back we were working on the Atari Punk console and I wanted to check something on the scope. So I pulled my big HP 150A out, which is an all vacuum tube oscilloscope that we went through quite a big ordeal to get going again, and I fired it up and it wasn't working right. The trace wouldn't stabilize at all on the CRT. It looked like it was kind of flickering in and out, and I'm pretty sure that's indicative of a high voltage problem. So what I want to do today is I want to pull the 150A apart again, try to figure out where the problem is, hopefully fix it, so that way we have our 150A back on the bench working perfectly, because it is by far and away my favorite piece of test equipment. However, I have also recently come into possession of some other old vintage HP equipment. So if we get the HP 150A going pretty well, I want to take a look at the other stuff that is sitting in the queue to be restored, and hopefully you guys can tell me which one you want to see the most. But first, we got to get the 150A going, so we'll pull it out, put it on the bench, take a look inside, and hopefully it'll be working by the end. So let's get to it. Alright, I've got the HP up on the desk with the case off of it, and we're looking in the very back of it. This is the high voltage section. I've actually also removed the plate around the high voltage box here. This is where the flyback is that generates the 5,000 volts that is used for the CRT itself. And I do believe that our problem is located to the high voltage section. I can actually hear it clicking in here whenever I've got the power on and this cover off, which is super dangerous, by the way. Never play around with high voltage. It's making me pretty nervous as it is. But I can hear some clicking in there, which tells me that probably I've got a leaking capacitor. Maybe that as the capacitor gets charged, it shorts within itself, and that's causing kind of a repeating loss of high voltage, which is why we're seeing the trace kind of flicker in and out. There's a handful of capacitors in here, particularly high voltage ones, that I did not replace. These two on the end and this one down here on the bottom, those are definitely 6,000 volt capacitors. Fortunately, I still have a bunch of these very nice WEMA caps left over from when I fixed the capacitor that was blown up here. These are all 6,000 volt capacitors, so they should work no problem in there. Now there's also 3 more high voltage capacitors up here on this board over here, and if I have enough of these WEMA caps left over, which I believe that I should, I will replace those 3 as well. However, I am fairly certain that those 3 are still somewhat functioning correctly and that the problem is pretty much located in here. But if these high voltage capacitors are failing, I might as well replace them all. The other thing that I want to replace while I'm in here is this little selenium rectifier right here. This is actually only a rectifier for a DC series heater string, and so that has absolutely nothing to do with our high voltage problem. But I've got the case off and I've got it open, and a lot of you guys warned me that when these things go, they tend to release the most toxic, horrid smell on the planet. And that is something that I really don't wish to experience. So I've got some new diodes that I can replace this with, but I also need to add in a series resistor because those diodes are going to have a lot less voltage drop across them. Now the good news is that the DC voltage that's coming out of this is actually adjustable via this potentiometer down here. It's originally intended to be adjustable. So I may be able to get away with a very small series resistance and pick up the additional slack with my potentiometer here. First things first, we need to get the HV section here out so I can get access to all the capacitors that need replacing. Once we get all the capacitors replaced, we will fire this thing back up again and see if that solves our high voltage problem. So let's get to it. All right, I've got it all back together now. You can see all of the high voltage WEMA capacitors are these red capacitors with the yellow base. I needed 5,000 picofarads, and the WEMA caps that I had were 3,800 picofarad and 1,500 picofarad. So I had to run those in parallel to get me to 4,800 picofarad, which should be close enough. But by running them in parallel, they're quite a bit thicker here, and I was really worried about this one in particular clearing the side here, but it seems to have all fit. I did run into an issue with these ones up here. I needed essentially 3 of these parallel combos right next to each other, and I ran out of room completely, so the third one over here had to kind of make this L shape around the bottom. It's not the most graceful solution, but, well, spoiler alert, it works, and it works really, really well. But if we take a look at the manual here and the schematic, the capacitors that I replaced are C109 and C110, and then I replaced C111, C122, and C123. These are the remaining high voltage capacitors that are hiding out inside that little box. And then finally I replaced C113, C120, and C121. That's these 3 capacitors that are sitting in parallel. These are not in the box. These are the ones that are on the bottom side of this board right here on the top. Now, with all the capacitors replaced, I set about working on the selenium rectifier. I just used one of these modern little silicon jobbies here. I did put a heatsink on it. Totally doesn't need it. I just thought it looked kind of cool. Now, these modern rectifiers often have less voltage drop across them compared to their selenium counterparts. And so you often need a series resistor to make sure that the voltage drop stays the same. But because HP put in this massive 4 ohm potentiometer here, I was hoping that there might be enough adjustment on there to get that 31.5 volts that we needed. And it totally did. I was able to hook the voltmeter up, check the voltages, and adjust this to get us right on to 31.5 volts exactly. And so let's hop around to the front of the scope, fire it up, and I want to show you guys what the trace looks like now because it's a lot better. All right, we've already got it on here, and I've got the input A reading off of the calibrator here. The calibrator is set to 0.2 volts peak to peak. And then we have our volts per centimeter set to 0.05. So there should be exactly 4 centimeters from the top peak to the bottom peak. And well, it's still extremely accurate. That is awesome. But most importantly, the trace is so much more precise. Before, the trace had a little bit of, I'm not sure how best to describe it, bloom, I guess. It looked a little fuzzy. The focus didn't have as much control as it has now, but more importantly, the intensity knob now has a ton of control. I can get to where it's really washed out and blooming out, or I can turn it completely off. Before, I did not have anywhere near that much control with the intensity knob. That is awesome. Those capacitors were very clearly on the way out, but as you can see now with the new capacitors in it, this thing is right back to being just an absolutely brilliant scope. So there we have it. I've got the case back on the big HP 150A here. I've also pulled out my HP 200 CD wide range oscillator. I've got it hooked up. It is putting out this absolutely beautiful sine wave, and it is working absolutely amazingly well itself. It's always been super rock steady. The square wave here on the bottom is coming from the internal calibrator down here, and I just did that to demonstrate that this is indeed fully functioning as a dual trace oscilloscope. The traces just look absolutely gorgeous. I have full intensity control and focus control. This thing is working at 100%. I am so happy to have my 150A back. But this is not the end of vintage HP test equipment on this channel. If we pull the camera back a little bit, you can see we've got a long road of HP restoration ahead of us. Some of these are brand new acquisitions, as in like I picked them up yesterday. This one, and this one are brand new. These three I have been waiting for me to get around to, but we have a bunch of HP equipment that we need to restore. The question is, what order should we restore them in? So going from smallest to largest, we'll take a quick look at what each piece of equipment is and what it desperately needs. And we'll start with this one, which is an HP 412A, a DC vacuum tube voltmeter. And as we can see is indicated on here, it can do ohms, it'll do milliamps, it'll do volts, but it only does DC. Now the biggest problem is that the bezel up here broke and something got in between the glass and the face behind it and just absolutely destroyed it. So I need to take a picture of this, or what's left of it, with a ruler next to it and recreate it on the computer. And so that way I can maybe print it out as a sticker, clean this off, and then put a sticker on there, and hopefully it'll look good. With the case off of it, we can get a look at the vacuum tubes. There are 5 vacuum tubes being used in this voltmeter, and they all look to be in at least a decent shape. I don't see any of the getters having gone white. I do see some black beauty capacitors over here, these 3 in particular, and those are definitely going to need to be replaced. If we flip it around to the other side here, we see a lot of point-to-point wiring, and we see this insane looking piece called a synchron, I guess. I have no idea what that is. It has 4 little light bulbs right next to it. There is a lot that we need to learn about this. But internally, it all looks pretty good, so it should work with fairly minimal effort. The biggest problem is going to be redoing that faceplate. Next up is this, which is an HP 400H. This is an AC vacuum tube voltmeter. It's very similar to the 412A that we just took a look at, only this one is for AC volts. The front glass here is broken. It's actual pretty sharp, so something needs to be done about that, preferably so I don't end up cutting myself on it. But the meter behind it looks to be in excellent shape. It's also important to note that this voltmeter doesn't use any special probes. It just has these little banana jack, I guess that's what those are called, banana plug jacks. It just has some of those for the input, and we have a little output over here. On the inside here, it all looks to be really clean. All of the tubes look totally clean, and all of the getters look to be intact, so I don't think any of them have gone to air. These big capacitors are probably okay. This little one here might need to be replaced, but other than that, it looks really beautiful inside. And it's really interesting how different the construction is compared to the 412A. If we flip this around and take a look at the inside on this side, there are some capacitors that most likely will need to be replaced. These Sprague capacitors, I don't know, they're probably fine, but I'd probably feel a little better if we replace those. Same with these yellow jacket ones here. And also there's a selenium rectifier down here on the bottom that probably should be replaced. But other than that, this voltmeter looks like it'll take surprisingly little effort to get going again. Actually, the most effort is probably just going to be in repainting the case and the bezel. Next up is an HP 711A. This is a DC power supply. Although I say DC, it does have some AC voltage over here. It has 2 6.3 volt taps at 3 amps each. You can actually run these in series for a 12.6 volts. This is obviously meant for testing vacuum tube circuits, because most vacuum tubes are running at 6.3 or 12.6 volts for the heater. Now the DC portion of it can go all the way up to 500 volts. The current meter here goes up to 100 milliamps, but I'm not sure if it'll supply 100 milliamps at 500 volts. Cosmetically, it's in pretty decent shape with the exception of this top right corner up here. The bezel has been broken, and it looks atrocious and has some sharp edges on it, so something definitely needs to be done about that. Now, there's not a whole lot of space inside the bezel. You can see that the main backplate here comes right up to the edge of the bezel, so there's not a whole lot of room to build up a framework behind there to put a filler on, so I'm not entirely sure about the best way to go about restoring this, but that'll be something that we can tackle when we get around to restoring this whole thing. With the case off of it, we can get a look inside of it, and it uses two 6L6 octal tubes for the, I guess, primary voltage control, and then there's a couple other small tubes here for other control. And then we have some big capacitors for smoothing, and other than that, it's pretty simple on top. But if we flip it over and look at the bottom, we can see that, like, unlike most of the HP equipment that I have, there are no printed circuit boards in here. Everything is point to point, and we actually just have a turret board over here. There are a couple Black Beauty capacitors here that should probably be replaced, and it looks like there was some rework done on these micro switches here, but it looked really well done, so I'm confident that those will work fine. There are some selenium rectifiers back here, and there's 3 more of them down here, so all of those should probably be replaced before we put this into heavy use. So aside from the rectifiers and these Black Beauty capacitors, the only real hurdle on this one is going to be trying to fix that bezel. Next up is this HP 211A square wave generator. This one is actually really similar to the 200 CD wide range oscillator, except this one puts out a square wave. We have a couple extra controls. You can see that we've got different amplitude controls here for a 600 ohm output or a 75 ohm output. We have some attenuation selection up here, and then like the 200 CD, we have a range selection that goes from ×1 to ×10K. We have this beautiful knob up top for adjusting the frequency. There are some stickers that I would like to remove, but other than that, the only thing that this thing is going to require cosmetic-wise is a cleaning and a new coat of paint for the case. Looking inside, surprisingly, this thing actually is mostly built on circuit boards. There's a printed circuit board here, and there's another printed circuit board up here on the top. It has more tubes in it than most of the other pieces of equipment that we've looked at. There's a whole suite of 6CL6s here, which are excellent pintodes. There's a 6080 in the back, a 5V3, and there's a couple more small tubes up here on the top. And then, of course, right here in the back, we have just the cutest little fan ever. This one looks to be in remarkable condition inside. There's not even that many capacitors that I need to worry about. There's a few Sprague capacitors here in the back on the range control, but other than that, there's no terrible Black Beauties hanging about or anything like that. This thing probably works as is. It just needs a little bit of a clean. Next is the HP 521A. This is a frequency counter, and I'm actually really excited about this one because I did a video about a year ago on the neon display units that are used in this. They're called the AC4, and I go into a lot of detail about some of the really trick stuff they do with the way that they run the flip-flops and the neon illumination in these. Now, this one I have had for a while, but I haven't tried to power it on because, well, it's just been waiting on me to finish the 150A. Cosmetically, it's in pretty rough shape. The case obviously needs to be stripped back and painted, but it looks like there was a sticker up here that somebody tried to scratch off, and well, they kind of marred everything up, and there's weird splotchy nastiness on it, so it needs a very deep clean. All right, now, unlike everything that we've looked at up to now, this thing is incredibly complicated inside. Right along the front here, we can see that we have 4 of the AC4 decade counter modules that we took a look at in a previous video, and these can actually just pop right out, and we can see it's pretty much identical to the one that we took a look at in that video, which is very cool. Although that one was an AC4G and these are AC4As. The construction is very similar. So there are 4 of those. Then we have some really big tubes back here, a 5U4GA and a 6AV5. We have a whole other module that looks like a plug-in module over here. And then if we flip the entire thing upside down, we can get a look at the bottom side of it. This is where the cooling fan is, and well, we can see that it has seen some use because this is disgusting. But also there's even more vacuum tubes hiding underneath here. And I can see right off the bat that the 5963 here has gone to air, which is a shame. So we have a bad tube. Look at that. That is a nice dual triode that is no longer nice. But you can also see that that's what a getter looks like when a tube has gone to air. But other than that one tube that went to air, everything else looks to be in decent shape. It is just filthy inside. So this one is going to need a lot of cleaning, but it should come back to life fairly easily. And finally, we have the HP 608D VHF Signal Generator. Now, I am not a ham radio operator, so this one I probably have the least amount of use for, but that doesn't stop it from being insanely cool. The gauges up here are just absolutely beautiful. I love the turn knob for the selection of the frequency here, which is all in megacycles. We've got a big, beautiful turn wheel down here. This thing is just a gorgeous piece of equipment. However, from a restoration standpoint, it doesn't really need that much. The case I will strip back and paint so that it is the same color as all of the other cases, which is going to be that kind of olive drab green. And that's pretty much it. Looking on the inside, it is impeccably well built. We can see that there are just turret boards full of resistors here. Everything is wired up with point-to-point wiring. We have a few tubes down here actually pointing upside down. Looking at it from the top, this big circular wheel here is just the display for the megacycles on the front. So whenever I turn that little knob to change my frequency, we can see that that little wheel turns as well. But the wheel itself has a shaft that goes straight down, and so I imagine that when you turn this knob, it's turning the wheel, but it's also changing something inside of the Black Magic box. There is a very large box that takes up about 60% of the volume in the case here, and it's all sealed. That is where all of the very high frequency Black Magic stuff is happening. I am not gonna open that up. If I do, it'll never work again. And I'm inclined to just plug it in and see what happens first instead of going through and replacing any capacitors that might look suspect, because of the delicate balance of electronics that has to go on in order to achieve the extremely high frequency stuff that it's dealing with. If I replace a capacitor with one that doesn't behave in exactly the same manner, it can throw the whole thing out of spec. So I think with this one, the best game plan is to just plug it in, fire it up, and see what happens. So there we have it, 6 big old pieces of equipment ready for restoration. The only question that remains is, which one do y'all want to see restored first? I am personally leaning a little more towards the frequency counter down here or the power supply up here, because I think I can probably get the most use out of these having them on the bench. But they're all beautiful and awesome, and I would be absolutely just over the moon to have any of them restored and working on the bench. They're also all going to require a very different skill set to work on. The VHF meter here is sitting in a class of test equipment that is so far out of my knowledge wheelhouse that I'm essentially starting from zero on it. The power supply up here with the broken bezel is going to require maybe a little bit of bodywork skills, and the voltmeter over here is going to require a lot of design skills on the computer to try and rebuild that bad label. So there's a lot of really interesting things to learn here, both electronically and non-electronically, and I am excited to work on these throughout 2022. So you guys let me know which ones you think are the coolest and which ones you want to see first, and I'm gonna get them off of the table now because I'm afraid this table is going to buckle under the weight. But I want to thank you guys so much for watching, and I hope to see you in the next episode.